So now we'll discuss about cyclotron. What is a cyclotron? Cyclotron is the device by which we can produce high speed, high energetic particles, high energetic charged particle. Now what is the use of high energetic charged particle? We can use to study the radioactivity, okay, to 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 put an ion in an atom, okay. For various requirement, we need actually very high speed charge particle. Now what to do, how we can produce high speed charge particle? We can produce high speed charge particle with the help of some electric and magnetic field, okay. So before starting cyclotron, we must know what happens to the charge particle when it enters to a magnetic field, how the magnetic field impacts the motion of a charged particle, okay. Let us study first this part. Suppose we have a magnetic field which is perpendicular to the board, okay, like this. This is the field, magnetic field, which is perpendicular to the whiteboard and towards the observer, okay. So in this way we represent a uniform magnetic field. Now we will consider the motion of a charged particle in this uniform magnetic field. Now suppose the charged particle is entering in this way at right angle and on the plane of the board. This is the charged particle, okay. Now this magnetic field will exert a force on the charged particle, okay. This magnetic field will exert a force on the charged particle. So if Q is the charge and V is the velocity of the charged particle and B is the induction vector of the magnetic field, B is the external magnetic field, then the moment charged particle enters into the field, because of the velocity of the charged particle, this charged particle will experience a force. Now how much is the force? This force is equal to F equal to Q into velocity cross the magnetic field, correct. Q is the charged particle into velocity into the magnetic field. Now it is a vector quantity, force is a vector quantity. In which direction the force will be experienced? See, the charged particle is entering like this, okay, in this way, and the force is like this, okay. So how to find out the direction of force? Keep your right hand along the direction of velocity and rotate it from the first vector velocity to the second vector magnetic induction vector. So thumb gives the direction of force, okay. So the charged particle will experience a force perpendicular to the velocity. It means that the charged particle will experience a force along this at right angle, okay. So any force which is at right angle will tend to move it like this, okay. How will be the motion? The motion of the charged particle will be circular in nature because the force is at right angle, correct. So this force will exert centripetal force. When a charged particle moves in a circular path, the force experienced by the charged particle is towards the center, it is at right angle. So this is the centripetal force. A charged particle circular path trace karega, it will cover a circular path. So and what is the centripetal force? Centripetal force is mass of the charged particle, v square, the velocity square, divided by the r. This force is directed towards the center, okay. So this force due to the magnetic field, if we expand it, Q into velocity into magnetic field, and the direction of velocity and direction of magnetic induction vector is 90 degree. sin 90 degree equal to m into v square by r, m square into v square by r, correct. So how much is the velocity, how much is the radius? So cancel out, sorry, okay. From this I can find out the radius of the radius of the circular path. R is how much? mv square by q v into b, q into v into b. So radius of the circular path is equal to mv by q into b, correct. This is the radius of the circular path, okay. Now what is the velocity of the particle? You can find out the velocity of the particle. The velocity of the particle is equal to q into b into r by m, correct. What is the angular velocity of the particle? Omega. Omega is v divided by radius, v by r. V is equal to how much? Q b by m, r cancel out. So this is the angular velocity. What will be the time period of the particle? You can find out omega is equal to 2 pi by t, the time taken to complete one rotation, okay. So you see the angular velocity is independent of this. Now omega, what is the time period? Omega is 2 pi by t. So time period equal to 2 pi by omega. Omega is q b m. This is the time period. Now what is the time taken by the particle to cover half of the circular path? T. Time taken to complete the half of the circular path. So half circular path, if r is the radius, then half path is pi into r, okay. This is the distance by velocity. So velocity is equal to q b r by m, q b r by m. So time taken to cover the half of the semicircular path equal to pi into m by q into b. What is the kinetic energy of the particle that is covering this path? Kinetic energy is equal to how much? Half into m into v square. So half into m into velocity square. Velocity square is how much? Q b m r by this, q b r by m. So we can write the velocity as this, okay. Say mv square equal to how much? You can find out mv square is equal to how much? Q v, you can write here from here. It is q square b square r square by m square, correct. So cancel out. So this is the kinetic energy of the particle, correct. This is the kinetic energy of the particle, that is q square b square r square by half q square b square r square by m. Now it means that we can find out the radius of the circular path, we can find out the time taken to cover the path, we can find out the half of the time required, we can find out the angular velocity, correct. We can find out the radius also. So when a charged particle enters at right angle, okay, the charged particles enters a right angle to the magnetic field, the charged particle executes a circular path. This is the principle of cyclotron. Now, how cyclotron is constructed? It consists of दो hollow disk रहेगा, hollow disk. It is in 3 dimension like this. Okay, I'm showing the section. एक section को show कर रहा हूँ like this. ये hollow disk है. Okay. Now a charge particle is placed here. Somehow we place a charge particle at this. Okay. Now there is a magnetic field. Magnetic field means what? Suppose the cyclotron is kept here. The magnetic field is perpendicular to this. So in this case, if the D's, these are called D. There are two D's. One is the right hand D, other is the left hand D. So we can name it like D1 and D2. So this is the these are the two D's, okay, and the magnetic field is perpendicular to these D's. So what will happen? The moment the charge particle will start moving, because of this external magnetic field, okay, the magnetic field is towards this. Okay, so I can write it like this, just to show in the similar way, correct? This is the magnetic field perpendicular to the disc. This is just to understand how it happens. This is perpendicular, uniform magnetic field is there. So what will happen? This charge particle will, the moment it enters, it will cover a circular path like this. Okay. Now here this distance is very small. Okay. Here we apply electric field. The electric field is applied. So what is the potential difference? dV by dr is equal to, intensity is defined as, electric intensity is dV by dr. So if the distance is very small, okay, and high voltage is applied here, the alternating high voltage alternating frequency is applied here, okay. So what will happen? Because of this electric field, it will experience a acceleration. The moment it exits from D1 and enters into D2, in this path electric field is applied, okay, and it is applied in such a way, this is a positively charged particle. The moment it covers the half path, this D becomes negative, okay, and this becomes positive. This is alternating voltage, okay, 10 to the power 4 volt, about 10 to the power 4 or 10 to the power 7 hertz. So if the alternating frequency between these two D's are applied in such a way, the moment half path is covered by this and it enters into the D2, this D becomes negative, okay. When this D becomes negative, then electric field is applied, so it gets accelerated. तो अगर accelerated हो जाएगा इसमें, तो जैसे ही particle का velocity बढ़ जाएगा, acceleration हो जाएगा, तो इसका radius ये नहीं रहेगा, it will spiral like this. Similarly, जैसे ही ये half D cross करके इस D से D2 से D1 में जाएगा, फिर ये क्या हो जाएगा, इसका जो polarity है, ओके, इसका पोलरिटी नेगेटिव हो जाएगा, ये पॉजिटिव हो जाएगा. तो ये फ्रीक्वेंसी इस तरह से सेट किया जाता है बिटवीन द टू डीज, सच दैट जैसे ही हाफ पाथ कवर करके सेकेंड डी में आएगा, इसका पोलरिटी चेंज हो गया, फिर इसमें एक इलेक्ट्रिक फील्ड अप्लाई हो गया, ये एक्सेलरेट हो जाएगा. सो एवरी टाइम इट मूव्स, द रेडियस इंक्रीजेस, करेक्ट. इट इज एग्जीक्यूटिंग ए, here we have a deflector through which it exits, okay. So in this way we are producing high speed charge particle, correct. This is the fundamental of cyclotron, okay. Now the advantage I told you about cyclotron. What are the disadvantage? We cannot accelerate a neutral particle like neutron. It should be a positively charged particle. Also, we cannot accelerate negatively charged particles. Electrons cannot be accelerated. Why electron cannot be accelerated using the cyclotron? The reason that, see, electron is a very light particle, okay, and the relativistic mass, Einstein has given that if we move a particle at very high speed, okay, then the mass of the particle is velocity dependent. Mass of the particle, when the velocity is v, is given by mass of the particle when its velocity is at 0, that is the rest mass. When velocity is 0, whatever is the mass is called rest mass, divided by root over 1 minus v square by c square. What is v? V is the velocity of the particle. What is c? C is the velocity of light. Now, electron being a very light particle, its mass is very less. So, what will happen? It will attain very high velocity. If the velocity is high, then the denominator is very less. If the denominator is less, then what will happen? This mass will increase. Okay. So, you cannot accelerate the particle. If the mass increases, then the acceleration stops. So, that is the reason. So, what you can say, why if it is asked, suppose तुमको ये पूछा गया कि इलेक्ट्रॉन को साइक्लोट्रॉन के थ्रू इलेक्ट्रॉन को क्यों नहीं एक्सेलरेट किया जा सकता? फर्स्ट ऑफ, इट इज नेगेटिवली चार्ज्ड. सेकेंड, दिस इज अ वेरी लाइट पार्टिकल. इलेक्ट्रॉन का जो मास है सबसे कम होता है, 10 to the power minus 31 kg. Okay, of the order of 10 to the power minus 31 kg. Such a light particle at very high speed will acquire a huge mass. सेकेंड क्या होगा? अगर उसका ये जो फ्रीक्वेंसी मैं एडजस्ट करता हूँ ना, कि जैसे ये आधा कवर करेगा और इधर आएगा, तो इसको मैं फ्रीक्वेंसी को एडजस्ट कर सकता हूँ. लेकिन अगर मास ही चेंज होगा पार्टिकल का, तो क्या होगा? इसका टाइम पीरियड जो है ना, ये इक्वल नहीं रहेगा, यूनिफॉर्म नहीं रहेगा, बिकॉज मास इज वेरिंग. तो हम इसको अल्टरनेटिंग जो चेंज ओवर हो रहा है, यहाँ पर अल्टरनेटिंग जो मैं दे रहा हूँ, है ना, अल्टरनेटिंग ऐसी, उसको मैं एडजस्ट नहीं कर पाऊंगा कि जैसे आधा कवर करता है तो चलो इसको मूव करेंगे. सो दिस इज हाउ द cyclotron works. Okay, so what are the uses of cyclotron? First of all, it is used to produce high energetic charged particles. So we use it to produce high energetic charged particles, although there is some limitation that we cannot produce energy of the order of some 500 million electron volt. We cannot produce, but we can use up to certain limit. It is used to produce energy of several million volt. Okay, high voltage can be produced. High speed positively charged particles are used for artificial disintegration of atomic nuclei. So in order to hit the nucleus, okay, we need, for artificial disintegration, in radioactivity this disintegration happens, atomic nucleus to be broken up. So for that we require high speed positively charged particles, and we use cyclotron to generate such high speed positively charged particles. So cyclotron supplies continuous stream of accelerated ions. Ions are the charged particles. Okay, these are the uses of cyclotron. We use cyclotron for these reasons. Now let us come, what are the limitations of cyclotron? What we cannot do with the cyclotron? We cannot use neutral particle to accelerate, like neutron we cannot use. Okay, it should be positively charged particles. So cyclotron cannot be used to accelerated particles like neutrons, which are electrically neutral. It cannot accelerate electrons, because if electron has a relativistic mass, its mass is very less, but as it moves, we have already explained that the mass of the electron is equal to mass at 0 velocity divided by 1 minus v square by c square. If we try to accelerate electron, its mass will increase, and if the mass increases, then we cannot set the frequency and we cannot even accelerate the charged particles. So lighter particles like negatively charged electrons cannot be used in cyclotron. Second, the third part of this limitation, that the charged particle cannot move with speed beyond certain limit. This is the reason for that, because if the speed is beyond certain limit of the order of light, velocity of light, then its mass also changes. This is called Einstein relativistic mass formula. Okay, when the particle moves, then its velocity is its mass is velocity dependent. Okay, it is not possible to produce highly energetic particles of the order of 500 million electron volt. Okay, formulas that we have studied in cyclotron. First of all, the centripetal force required to move in the circular path is obtained from this q into v cross b. From this we find the radius of the circular path, which is mv by q into b. M is mass of the charged particle, v is velocity of the charged particle, q is the charge in that particle, and b is the magnetic field induction vector. So from this equation we find that the radius is proportional to the velocity. Okay, higher is the velocity, higher will be the radius. That is the reason it is spiraling. The radius is not fixed. Okay, when it grazes the surface, then it exits. There is a deflector, and we allow the particle to exit through the cyclotron. Half of the time period, that is time taken to cover the half of the d, is given by pi m by q into b. This also we have derived. The time period, that the time taken to move a complete circle, equal to 2 pi m by just the twice of this, 2 pi m by q into b. Okay, so it rotates with a very high speed and loops about 1 lakh times in this. Such high is the frequency of this alternating voltage. This is called the cyclotron frequency. The frequency of this oscillating alternating field that is applied between the D's is same as the frequency of the charged particle which is moving. So the frequency is given by reciprocal of time period. This is equal to q into b by 2 pi m, just reciprocal of this. And the kinetic energy of the charged particle in that cyclotron is given by q square b square r square by 2 pi m, where r is the radius. Okay, so you can consider the average radius, because radius is continuously increasing. This is the average radius. So that's all about cyclotron.